Hi friends, in this video I'm going to talk about clustering. So what is clustering? Imagine you have a ton of Lego blocks of different shapes, sizes spread out on the floor. It's time to put the Legos away and you realize that you don't have a large enough bin to store all of them. Luckily, you find four smaller bins that can each hold roughly the same number of pieces. You could dump random assortment of Legos in each bin and call it a day. But then next time you went to find a specific piece and you didn't quite thus time digging around. Instead, you have a better idea. Why not put similar pieces in same bin? Would you save time and trouble later? But what criteria do you want to follow to put Legos in each bin? Are you going to assign a specific bin for a different color or put the small square pieces in one bin and the circular piece in another bin? It really depends on what Legos you have. In the nutshell, this is what this clustering is. I hope the example was good enough to make you understand a basic gist of what clustering is all about. Mostly we use clustering analysis as a technique for grouping data points. The clustering algorithm takes a bunch of objects and spit out assignments for each object. Unlike classification, however, clustering does not start with a list of classes to categorize the objects, forcing the objects to fall into preset buckets. Rather, clustering attempts to discover the buckets given the data. In the other words, clustering is about uncovering structure in the data, not predicting labels in pre-existing structure. This last point merits repeating. Clustering is not about predicting labels, unlike classification, detection, and segmentation tasks. There are no ground truth labels clustering tasks. We call algorithms like unsupervised, contrasting with supervised, and self-supervised learning tasks to label the data. To hammer it home, clustering is training free. A clustering algorithm will take in features of your data points, the objects, use those features to split your objects into groups. When successful, those groups highlight unique characteristics giving you a view into the structure of the data. This means that clustering is an extremely powerful tool for exploring your data, especially when the data is unlabeled. So how does it work? So normally there are three different formats of clustering what is used when any algorithm has to be run on a data for labeling purpose. You can use centroid based clustering, you can use density based clustering, and you can use hierarchical clustering. So let me dwell a bit on centroid based clustering. So this clustering use techniques like k-means and mean shift clustering. These methods try to find center point by which to define each cluster called centroid. So this algorithm basically assumes that each data or each cluster would have centroids. So it tries to locate those centroids and find out the clusters as per the centroids, which seek to maximize some notion of coherence between points within a cluster. This flavor of clustering scales well to large datasets but is sensitive to outliers and random initialization. Often, multiple runs are performed and the best one is chosen. You may find this technique like k-means struggle with high dimensional data. The curse of dimensionality is what we normally call it as, and can better uncover structure when paired with dimensionality reduction techniques like uniform manifold approximation and projection, also called as UMAP. Second is density based clustering. It includes techniques like DBSCAN, HDBSCAN, and optics, which select clusters based on how sparsely or how densely populated the feature space is. Conceptually, these algorithms treat high density regions as a cluster, breaking clusters off when points become sufficiently spread out in feature space. Simple density-based techniques like DBSCAN can have different difficulty working with high dimensional data, which where the data may not be densely co-located. However, most sophisticated techniques like HDB scan can overcome some of the limitations and uncover the remarkable structure from the high dimensional features. Hierarchical clustering, wherein you either construct or deconstruct clusters. When we say construct clusters, it means by starting with individual points and iteratively combining clusters into large composites. Or second is deconstruct clusters, that is starting with all objects in one cluster and iteratively driving clusters into smaller components. Constructive techniques like agglomerative clustering become computationally expensive as the dataset grows, but performance can be quite impressive for small to medium datasets with low dimensional features. Last is clustering images with 51 and scikit-learn. We will be leveraging two open source machine learning libraries which are scikit-learn, which comes pre-packaged with implementation of most common clustering algorithms, and 51, which streamlines the management and visualization of unstructured data. So 51 clustering is something, but it's a plugin which makes our life even easier. It provides a connective tissue between the scikit-learn's clustering algorithms and our images and wraps all of this in a simple UI within 51 app. We can install the plugin from the CLI. So if you want to delve deeper into this algorithm, I encourage you to in fact do some Googling on finding out how to implement 51 along with scikit-learn in your own projects. Thank you very much.